Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Problem 3.15. The statement of problem is that allowable shearing stress is 15 ksi in the 1.5 inch diameter steel rod AB. So this is a steel rod AB having diameter 1.5 inch and 8 ksi in 1.8 inch in diameter brass rod of BC. So BC is the brass rod and its diameter is 1.8 inch. Neglecting the effect of stress concentration, determine the largest torque that can be applied at point A. So let's start with the given data. As we know that the rod AB is made up of steel and allowable shearing stress in steel shaft or AB is equal to maximum shearing stress in AB, and that is given as 15 ksi. So that is 15 ksi. Again, the diameter of rod AB, which is for steel, is equal to 1.5 inch. So its radius C of AB will be equal to 1.5 divided by 2, and that is equal to 0.75 inch. Now for brass allowable shearing stress for brass B, and that is equal to maximum shearing stress in rod BC, and that is also given. There is 8 ksi. So again this is 8 ksi, and diameter of rod BC is given as 1.8 inch. So radius of BC will be equal to 1.8 inch divided by 2, which is equal to 0.9 inch. Clear? And what we have to find? We have to find the largest torque that can be applied at point A. So we have to find torque, and that torque must be the largest. Clear? At point A. So let's start with its solution. As we know that maximum shearing stress is equal to T into C divided by J, or it is equal to 2T over pi C Q. Also we know that J is equal to pi by 2 C4. So we will start from shaft AB. For shaft or rod, we will use the term rod, not the shaft, because shaft is rotating element and this is not a rotating element. So for rod AB, as we know that maximum shearing stress is equal to 2T 2 into T over pi C cube. We are interested to find out torque. So this torque will be equal to pi C cube into maximum divided by 2. Again this torque will be in torque in rod AB. So that will be equal to pi C, for this is 0.75 for AB, that is 0.75, and maximum shearing stress in rod AB is 15 ksi. So 15 divided by 2. So we can calculate it, and this torque in rod AB comes out to be 9.94 kips into inch. Similarly, we can can also find torque in rod BC, and this torque in rod BC will be equal to, again, that will be equal to pi into C cube, but this C will be BC into maximum shearing stress for BC over 2. So again you can put the value, pi will be there, and CBC is 0.9 whole cube. I just forget to put the cube over here. It is 0.75 whole cube there. Now maximum shearing stress in BC is 8 ksi, so 8 divided by 2. So if you calculate it, torque in BC comes out to be 9.16 kips into inch. Now you have two value of torque. One is the torque in AB, rod AB, and one is the torque in rod BC. Now you can see this value is greater than this, so we will select the minimum torque as our answer. So the allowable, I will also explain why we are taking the smallest value. So allowable torque is T of BC is equal to 9.16 kips into inch, or we can say that is smaller value of torque, or choose smaller value of torque. That will be the answer. Why? The reason is that we have two value of torque. One is the greater value, and this value is 9.94, and the second one is 9.16. If we choose this, so again if you put it in this equation, this will give you the same maximum shearing stress. But if you put the value of torque 9.94 and you place it in the maximum shearing stress equation, 2T over pi C cube for rod BC, so its value will comes out to be greater than 8 ksi, means it will cause disruption in BC. But what if we choose the smallest value, this torque? So if you put it in this equation, so this maximum shearing stress in rod AB will be less than 15 ksi, which is acceptable because the maximum stress is 15 ksi and the minimum is acceptable. And if you put the same value in this equation, so the maximum shearing stress will be 8 ksi. So again this value, the smallest torque value, is acceptable as our answer. I hope you have enjoyed the video, and if you like my video, kindly subscribe, like and watch. Thank you.